in this lecture, we will talk about parametric equations. We look at the example first, and then we will be introduced a definition for parametric equations. This example says that find an equation in x and y whose graph contains the points on the curve C. So right here is that we are requested to find an equation in x and y, means without t, and then whose graph contains the points on the curve C. So here we are given t, and then in the equation we don't want t. That's what it says. Okay, here t is restricted from 0 to 5, and 0 and 5 are included. You can also write t is in between 0 and 5 with square bracket, means 0 and 5 are included. Ask us to sketch the graph of C and indicate the orientation. So here we are also requested to find out is the graph goes clockwise or counterclockwise, or goes down or goes up, or goes from the left to the right, or from the right to the left. Okay, so we got to figure out that. Here there are certain steps we need to follow. Okay, now let's look at step 1. Step 1 is that we may let t choose 3 or more different values between 0 and 5. Okay, normally we should choose 3 or more, not 2. 2 is sometimes you can choose 2, but 3 is better. 3 or more is better, so you can see clearly the orientation. And if you have more points on the curve C, you may have you could have draw very good pictures, graphs. Okay. Now let's choose the 3 different values. Starts with smallest one. You have to start with the smallest one, or smaller one. You may not start with 0. But here let's start with 0 and end with 5. So x, t choose 0, then 0 minus 5 is x, 0 minus 5 is negative 5. Since y equals 2t plus 5, so 2 times 0 plus 5, 2 times 0 is 0, plus 5 is 5. So when x is negative 5, y is positive 5. So you have this pair, negative 5 and 5 is on the curve. Now you may choose another one. Another one may be 1, 2, 3, or 4. Okay, here I chose was 1. So x equals 1 here, and then 1 minus 5 is negative 4 for x, and 2 times 1 plus 5 is 7. So then x equals negative 4, y is 7. So then negative 4, 7 is on the graph. Okay? Alright. Now, step 3, the third value we are going to choose is the last one, 5. So when x equals when t equals 5, the last value we choose for t is 5. So when t is 5, 5 minus 5 is 0 for x. And then 2 times 5 plus 5. 2 times 5 is 10 plus 5 is 15. Okay, so here we have another pair. 0, 15 is on the graph. Okay. Now, well, 3 points. We know when t increases from 0, 1 to 5, we have 3 points. Negative 5, 5, negative 4, 7, 0, 15. So we know the graph will go from negative 5 to 5, from 4 to negative 7, from negative 4, 7, and then to 0, 15. So starting with negative 5, positive 5. Okay, so here will be negative 5, positive 5, and negative 4, 7. Okay, and then 0, 15. 0, 15. So you know the picture, a curve goes from this point to this point to this point. So you know the curve goes up. Is this really a line? We don't know yet. But we know it goes like this. To see if this is really a line, we got to eliminate the parameter, which is t, because we are requested to find an equation in x, y without t. Okay. Now, so if we don't want t, you see there are 2 ways. But here to eliminate t, there are 2 ways. Here I will introduce you one way is use x to express t. Okay. Actually is substitution. Okay, x is given as t minus 5. So both sides add 5. Okay. Then you have a t equals, because this positive negative 5 is cancelled. Okay. So then you have a t equals x plus 5. Now, t equals x plus 5, you put it back here. So you will then have a y was 2t plus 5. So y was 2t plus 5. Now t is x plus 5, so you put it in. We replace t by x plus 5. So that's eliminate t by substitution. Okay, now 2 times x, 2 times 5, distributive property. Okay, 2 times x, 2 times 5. You then have 2x plus 10, and then plus 5. Okay, and then 10 plus 5 is 15. So y equals 2x plus 15. Apparently, this is a slope-intercept form of a line. Okay, and you know actually this one was a line, but line segment actually is because t is restricted from 0 to 5, from this point to this point, t. If t is 0, then you have negative 5, positive 5. Okay, x is negative 5, y is positive 5, so it's this point. Okay, so there are 2 steps, and then we know t needs to choose from the smallest to the biggest. Then you know the orientation is from lower point to the top point, and it's only a line segment. Okay, line segment. And then here, we know this after t is eliminated, we know this is a slope-intercept form. So we know this is the equation of a line. All right. Now we are clear about this example. And here is the definition for parametric equations. Okay, based on this example, we may introduce some terminologies right here. Let C be the curve consisting of all ordered pairs f of t, g of t. Here f of t is t minus 1, and here you know that's the place for x. The first coordinate is always x, second coordinate is always y. Okay, so x equals f of t. F of t in this case is t minus 5, and y equals g of t in our case is 2t plus 5. Of course, this f of t and g of t can be quite different. We'll see more examples later. Now, where f and g are defined on an interval, means down here, this example, t is from 0 to 5. Okay, this is a closed interval, means 2 points, boundary points, 0 and 5 are included. Okay, and then the equations x of t, x equals f of t, y equals g of t, for t in I. T in I means in the interval from 0 to 5. Okay, t is right here in I, this interval. Are parametric equations for C with parameter t. So those two equations are called parametric equations for the curve. In our case, is a line with parameter t. Okay. Now, then we know those two are parametric equations now. And then the orientation of a parametrized curve C is the direction determined by increasing values of the parameter. So here, when you choose value t, make sure you choose is from the smaller value to the big value. Then you know the orientation. Okay, don't choose from bigger t to the smaller t. Then you got opposite direction. Okay, for the orientation, you always want to increase t from smaller one to the big one. Then you will find out the orientation. That's what it says. Okay, yeah, the orientation is determined by increasing values of the parameter t. Okay. Okay. Here, by using this example, we have introduced the parametric equation. X coordinate equals a function with parameter t, and y coordinate equals another function with parameter t. Okay, and the orientation is always can be got by increasing value t. Okay, and this basically is the definition, the introduction for parametric equations. Okay, I'll see you next time.